Okay, make sure you're following now, okay? 16. We did simple interest. Now there's going to be compound interest. Compound interest is different than simple interest because the interest you earn is earned on both the principal, the original amount, okay guys, and the amount you're earning along the way. Okay guys, so it's gonna be a snowball effect. It's gonna grow faster. So I'm just gonna give you a heads up. Do you remember what the graph of simple interest growth looked like? Do you remember? Straight line, correct? If you have time and money under a compound interest situation, it's gonna start here somewhere and it's gonna do this at first and then all of a sudden it's gonna shoot up like that. Okay? Exponential, yes. It's like population growth. It's exponential. So that's how this is different, okay? I'm not saying that compound is always better than simple interest, like you have to do the math. But if all else is the same, compound wins every time. If everything else is the same, like the initial amount, the time, the rate, then you want to go at compound, right? But don't always think, oh, compound is always better. It depends on how much money is involved and time and all of that, okay? Most financial institutions, right, banks, credit unions, they use compound interest. Compounding period refers to the amount of times the interest is calculated in a year. Compounding periods tells you the amount of times the interest is calculated in a year. So if you see the word compound, I'm going to use a different color just to contrast. This is important here. If you see compound, you cannot use simple interest formulas. You cannot. I equals PRT is dead in the water. It doesn't work, okay? You no longer will be using that one. So how will you know when to use simple interest, guys? The question will say simple interest. Somewhere in the question it will say simple interest. So there's no doubt in your mind there's a simple interest. If it says compounding periods, you know you're in compounding, okay? Since you are earning interest on previous interest, okay, you're earning interest on previous interest, there's a snowball effect, okay? It will grow faster. And so it's exponential. There it is again. I'm repeating myself, I know. In general, we start with an investment, right? The investment is the principal, and we expect to earn interest. The value of the investment after a period is called the future value. Same concept. We've got our principal, we've got the future value. And so when interest is compounded annually or per annum, it's the same thing. The formula looks like this. I don't want you to have this one here. I'd rather you use the one that I'm about to give you down here. When the compounding periods change, it affects both the interest and the exponent. So this is a must. Have this box. Have this boxed in. This is the compound interest formula. But I will tell you this. You can use this formula, or right now you don't know what it means. Maybe some of you do know. Down the road you'll be able to use the TVM app. So there's an app on the phone, on the calculator, that you will be able to use instead of this. If that's your preference, it's honestly going to be my go-to most of the time, but part of this curriculum is telling us that we need to teach you how to use that formula as well. Okay? For some of you, you might need this box as well. I would say, in my opinion, this is very important to know because you're going to need to know your compounding periods, how often interest is calculated. If the question says annually, it means once a year. Monthly, 12 times a year. Quarterly, 4 times a year. Can I say something about quarterly? It would be the same as saying every 3 months. Sometimes students are thrown off by a question saying interest is compounded every 3 months. It's the same thing. It's quarterly. Okay. Bi-weekly, 26 times. Semi-annually, 2. Semi-monthly, 24. 26 and 24 is often misrepresented. So bi-weekly is every 2 weeks. I will write that down. Every 2 weeks is the key word for bi-weekly. Semi-monthly is twice a month. It's not the same, okay? Every 2 weeks is every second week, twice a month. It happens 2 times every month. So you have 24 instead of 26, right? Weekly is 52. So I think most of you would need this box as well, in my opinion, okay? And I'm going to do this again because it's very important that you understand this. This is study sheet material. Always recall that to figure out the interest, you take your future value, you subtract the principal. I want this to be a broken record that you just know, right? I want to sound like a broken record where you're just like, yeah, I know, right? That's always true. Also, simple versus compound. Simple always looks like this. Constant growth. Compound looks like this. Exponential. Constant. Exponential. And I'll give you a scenario. I've seen this a couple years ago on the Provincial, where they compared both of them on the same graph. Let's say this is 1,000. Let's say this is 1,000 and this is 2,000. And let's say one person deposits $2,000 at simple interest, and it just grows. Right? And let's say another person deposits $1,000, and it grows, and all of a sudden it surpasses the simple interest. There's a point where you have to decide which one is better. And it all would come down to that intersection. Okay? Up until that point, from the very beginning to wherever this, simple is better. I will call simple wins. But after, like as time goes by, right? Simple is better, but then all of a sudden, it's the compound one that wins. And I would say, in the long run, compound will always win. And if you have long enough to wait, compound wins every time, because it does that. Is that point where it just all of a sudden just skyrockets, right? And the simple interest just can't win, right? So is simple always better? No. It depends, okay? It depends. Okay. Let's keep going. If I go a little bit too fast, you can I'll put it back up towards the end. It's also on the video. So Greg is 15 years old and inherited $150,000 from his grandmother. He would like to invest so he can use the money to purchase a house when he turns 25. He has the following options. Option A, 4.5% interest rate compounded monthly, or 4.5% interest rate compounded semi-annually. Calculate the future value of each option. Okay, do you see the word compounded? Can you use simple interest? You cannot. You got to use the other one. So I will do option 1 here, option 2 right beside it. If something is compounded monthly, how many times is it compounded a year? 12 times, right? N in this case is 12. N stands for the compounding periods per year. If it's semi-annually, how many times in a year is interest compounded? 2. Semi-annually. It's right here as well. I copy-pasted it. I need to clarify what compounding means. You ready for this? Compounding means the amount of times the bank calculates the interest on your investment. That's what compounding is. So if the bank says, hey, we're going to compound your investment 12 times a year, that means that every month they're going to calculate the interest and add it to your investment and add it to your investment, right? Every month. Whereas this other one here, only twice a year. So if you invest in January, they'll do it once in June, and then they'll do it in December, June, December, that's it, twice a year. Which one do you think, if you just a gut feeling, which one do you think would be better? More times, more often, or less often? Option 1. Yeah, is that your gut telling you that? Yeah, your gut, you should trust your gut on this one. Yeah. Monthly, the more often you compound, the better. So daily would be even better. If everything else is the same, if the interest rate is the same, more compounding is better when you're investing, okay? You're gonna get more money. So let's do this. I will show you the formula. That is the compound interest formula, okay? A is equal to 150,000 times 1 plus, I gotta turn my interest rate into a decimal, okay? 4.5% is 0.045 divided by N. N is 12 to the power of 12, that's N, times T is time in years. I know I went a little fast on the previous page, but how many years are going by here? We're starting when Greg is 15 years old, and we go to 25, so 10 years, right? I will just do this. Time is 25 minus 15, so it's 10 years. Okay, so I go times 10. This number right here, I had to do a little bit of digging to come up with the time in years. And now you can actually plug that all in one shot because we got awesome calculators, but I won't at first. I will clean this up a little bit, so watch what I do. Clear your screen. I'm going to go 0.045 divided by 12, hit enter. Then I will add 1 to it, so plus 1. So whatever's inside that bracket turns out to be 1.00375 to the power of 12 times 10. I think we can all do that one in our heads, but it doesn't hurt. It's 120. So over 10 years, right? over 10 years, and if it happens 12 times a year, the bank will have calculated your interest 120 times. Does that make sense? That's what that exponent is telling you. So let's plug it in one shot right now. I'm going to go 150,000 brackets, 1.00375, or you can copy paste, whatever works for you. Use the hat button to do the exponent. So you will have $235,048.92. That's A. Okay. For B, I'm going to do the exact same thing. Make sure you have this formula by tomorrow, okay, on your study sheets. Still 150,000. 1 plus 0.045 divided by 2, because it's semi-annually, right? And so this will be 2 times 10. If you allow me, I'm going to go to the 10 over here where I calculated, just go arrow. Just say we're using the same time frame. And in this case, I'm going to go 0.045 divided by 2, hit enter, plus 1. That is 1.022520. So I'm going to go 150,000 times, I'm going to copy paste, why not? To the power of 20. So in this case, they're only going to calculate it 20 times in 10 years. And what do you have here? Right? 234.76. Is it, can you see that option A is better? But not by a whole lot, right? We're talking $1,000 or so. But it's still better, right? Option 1. I'm going to leave this here. And I'm just going to ask you to try. I want to ask you to try a few questions. Page 23. Just page 23.